Have you ever experienced this? You have to make a knowledge clip video for your course, but you just can't bring up the motivation. You start watching endless Instagram reels to distract yourself, but this makes you even more stressed, depressed, and unmotivated. As a result, it becomes even harder to start working on your assignment. This is a feedback loop. A feedback loop occurs when the output of a process influences its own input. Positive feedback loops amplify themselves, causing a vicious cycle, while negative feedback loops decrease or dampen their own input, having a regulating effect. Feedback loops found in nature are often regulatory, keeping systems in balance. However, disruptions to the climate can put new feedback loops in motion, which can have very severe outcomes. An extreme example is the Permian-Triassic extinction, one of the 5 mass extinctions. Major volcanic eruptions caused global oceanic warming, releasing methane from frozen seabeds, which in turn caused more warming due to greenhouse effects.
Similar to the volcanic eruptions Kai talked about, humans causing climate change are altering feedback loops worldwide. And this happens at multiple scales. It happens at the global scale, it happens at regional scales, and it happens at local scales. And understanding these feedback loops is essential, as knowing what the future impacts of climate change are going to be can help in mitigating these impacts. And we understand if this far the concept feedback loop is a bit vague. So therefore, let's give some examples and make it more concrete. One example of a feedback loop that occurs at a global scale is the albedo effect. As the sun shines on the Earth, light surfaces, such as ice, reflect a lot of sunlight back into space. And darker surfaces, such as sea or land or vegetation, they absorb more energy from the sun. And as, due to climate change, the Earth warms, more ice melts, causing more darker surfaces to be exposed, which causes more sunlight to be absorbed. This, in turn, causes the Earth to get warmer again, creating a positive feedback loop. A more regional feedback loop is precipitation in the Amazon. In the Amazon, water is recycled, meaning that water evaporates in one place, then gets blown towards the Andes, where it rains down within the Amazon, and then it flows back to the same place towards the Atlantic. However, logging disrupts this cycle, as logged areas evaporate far less water. And when less water evaporates, it also rains less. And when it rains less, there's less water available, and less water flows back towards the Atlantic, causing less water to evaporate again. This positive feedback loop is suggested by research to have major impact on the precipitation patterns in the Amazon.
Climate change can also affect feedback loops found at the species level. Global warming causes longer growing seasons in temperate regions, with longer blooming periods. Longer blooming periods result in an abundance of food availability for pollinators, like bees and butterflies. This leads to higher survivability of their populations. More pollinators can result in improved plant reproduction, increasing flower abundance again. Not all feedback loops amplify the effects of climate change, as the ones in the last 3 examples. Some can also dampen it. This is one example. Due to higher CO2 concentrations in the atmosphere, photosynthesis rates of plants can increase. An increase in photosynthesis leads to more CO2 being captured in plants and organic matter, thus reducing CO2 concentrations in the atmosphere and dampening the original effect. There are many more examples of feedback loops altered by climate change, but the point we are getting at is, changes in feedback loops occur at different scales, and feedback loops have major consequences for local and global ecosystems, especially in the light of climate change.
And although feedback loops are very complex, identifying general patterns and monitoring changes can provide insight on how local, regional, or global systems respond to climatic disturbance. A better understanding of feedback loops can therefore help take action against climate change and guide conservation efforts to be more effective at mitigating negative effects. We hope you now have a better understanding of feedback loops, and until next time.